Hi, my name is Roman Pramanik. I am presenting our work EgoVLPv2 Egocentric Video Language Pre-training with Fusion in the Backbone, where we introduce the second generation of Egocentric Video Language Foundational Model. There exist four different categories of video language pre-training systems. Firstly, dual encoders, which do not have any interaction between unimodal backbones and hence cannot learn strong cross-modal features during pre-training. Next, encoders with stacked fusion layers and shared encoders which learn good multimodal representation but use a large number of fusion specific parameters. In this work, we introduce fusion in the backbone. Our model is flexible enough to easily switch between dual and fusion encoders and uses 45% lesser compute compared to stacked fusion layers. Our overall framework uses three different objectives: EgoNCE, masked language modeling, and video text matching. We use time transformer and Roberta as our unimodal backbones. We introduce gated cross attention in the top few encoder layers. This cross attention can be switched on or off, increasing the flexibility of the overall system. EgoNCE requires unfused video and text features. Hence, we compute EgoNCE with dual encoders. On the other hand, MLM and VTM requires multimodal representation. Hence, we switch on the cross attention modules. MLM and VTM are computed with fusion encoders. At last, the three different losses are added and backpropagated end to end. We introduce cross attention cascaded with the traditional self attention of transformer layers. For time transformer, at first, space time self attention is computed. Next, cross attention takes place with the query of the video modality and key and value from the corresponding layer of text modality. Notably, we use a gating scalar alpha to control the effect of cross attention. Alpha is a learnable parameter initialized at 0. Similarly, for Roberta, we also compute self-attention and cross-attention. Such simple idea of inserting cross-attention in the backbone helps us to learn strong multimodal representation during pre-training. The flexibility of the proposed architecture helps us to cover a wide amount of egocentric downstream tasks. Since the proposed gated cross attention can be switched on or off, we can use the pre-trained model both as a fusion encoder and the dual encoder. For some stuff like video text retrieval, we use our model as dual encoder, while for tasks like video grounding, video question answering, and query focused video summarization, we use EgoVLPv2 as a fusion encoder. We pre-train our proposed system on the EgoCliff version of Ego4D. Our system achieved effective result on 8 different tasks across 5 different datasets. Detailed results can be found in our manuscript. We perform ablation experiments on 3 different objectives. We observe that all three objectives are important for good performance. Moreover, the flexibility of the proposed fusion in the backbone module helps us to boost retrieval performance using an ensembling strategy. In this slide, we show text to video cross attention from multiple texts in the last layer of EgoVLPv2. We look at the attention map of the CLS token from the text encoder on input video frames. Different heads depicted in different colors focused on different objects or different parts. These maps show the strong cross-modal representation learned by our model during pre-training. In this slide, we show another example. Here, we present some qualitative results on EgoNL2 task. Our model clearly performs better than the dual encoder-based baselines. Although EgoVLPv2 learns impressive cross-modal representation during pre-training, there are still some cases where the model fails to identify tiny and hindered objects, especially in cluttered environment. Higher resolution frames will be more helpful in addressing such scenario, which we plan to explore in future. Here are the primary references of our work. To summarize, we advanced a step forward in egocentric VLP by proposing EgoVLPv2, the second generation of EgoVLP with cross-modal fusion in the backbone. Our proposed framework can switch between dual and fusion encoder and requires 45% lesser compute than learning additional fusion-specific transformer layers. We demonstrate the effectiveness of EgoVLPv2 on 8 different benchmarks and achieve state-of-the-art performance among comparable size backbones. In future, we explore several other egocentric tasks which will empower the VR and AR devices for daily use. Our model and code base is publicly available. Thank you. See you in the poster session.